Okay. So today we're talking about rules for exponents, and we're going to do 4 rules today. We're going to do the product rule, we're going to do the quotient rule, and then we're going to do zero and negative. We're going to practice these. We're going to learn more rules tomorrow, but we're going to practice all of the exponent rules for 4 or 5 days because I want to make, they're super important when it comes to solving equations. You don't need, it's not working? Okay, is it working now? Hmm. How do I fix that? Help me out. Hello, translate. Hmm. It's not hooked to a speaker, maybe? Sounds. All right, we're gonna have to have Miss Sarah look at it because I don't know. I'm gonna try to go nice and slow. If you have a question, stop me, okay? This is pretty visual. So today we're working with the product rule. That's what we're gonna start with. So the first word that we have as a vocabulary word is the word monomial. Okay, so underline that word. Oliver, I want you to close your Chromebook. You don't need it open. Okay, close that up. You don't need it open. So the word monomial, you guys learned this word. You've probably been using this term, this idea, since 6th grade when you started combining like terms. A monomial just means a term. Why doesn't it say term? Yeah, why doesn't it say term, right? That's what that means, okay? A monomial is a term. So remember that terms are joined with multiplication. Okay, so I'm going to give you a bunch of examples of a monomial because I think that that's important that you see a bunch of different types. So a term could be something, or a monomial could be something like the number 1 or the variable x or 3y. That's joined by multiplication, right? 3y means 3 times y. Or 4x to the second power y. That's a monomial. All of those are joined by multiplication. So terms are just, monomials are just terms. It can be a number all by itself, but we're talking about exponents. So typically it's going to be a number raised to a power or a variable raised to a power. Does that make sense? Okay. Yesterday we talked about this right here. We talked about 5, like the number on the bottom is the base, and it's going to be the factor, right? It's the number that we use over and over again. It's called the factor. And then that exponent tells us how many times that factor repeats. Okay. Do you guys feel all right with that? Okay. So the first rule that we're going to talk about is the product rule. And if I'm going too fast, I want you to stop me. Okay. So here's what this rule says. The product rule says that if you're multiplying 2 numbers, and it says 2 numbers, but it's really 2 terms, right? With the same base, you just add the exponents. So your example, a to the power of m times a to the power of n This is your base, and you would add the exponents. Well, I think that's a terrible example because you just have a bunch of variables. That doesn't make a whole lot of sense to me. So let's use these numbers. Let's use these numbers instead and see what we can figure out. Okay. So I am going to start with this first one. So 5 to the second power times 5 to the sixth power. Is the base the same? Yes. So we keep the base. And then since we're multiplying, we add the exponents. But what is that when we simplify it? 5 to the what? 5 to the eighth power. Okay. I'm going to tell you why that is. I'm going to show you something because I think this visual will help you. Do you guys remember yesterday we talked about what this means? 5 squared means 5 times what? 5 times 5. And 5 to the sixth power means 5, 6 times, right? 5 times 5 times 5 times 5, 2, 3, 4, 5 times 5. So that's what's taking place. This is the first one, and this is the second one. Do you see that? That's really what's happening, okay? We're just trying to teach you a cheat to not have to expand that all of the time, right? I'm just trying to teach you a trick or a shortcut so you're not expanding that all the time. So 5 squared, 5 times 5, times 5 to the sixth power, you're just adding those two numbers because if you were to count these, I have 1, 2, 3, 4, 5, 6, 7, 8. So this method right here, that's the shortcut, right? Does that make sense? Okay. So thinking about that, if I were to expand this one, that would be y times y times y times y times y 3 times, right? Y times y times y. When I use that rule, I just have 4 plus 3. I'm confused. Zach, I thought you were raising your hand. Zach M. I thought you had your hand raised to share something. No? Okay. How many do I have across the bottom when I expand that? 1, 2, 3, 4. Yeah, 8. But 4 plus 3 does not equal 8. You have one more y. Do you guys see this y right here? It doesn't have an exponent there, but it really is to the first power, right? We just don't write anything to the first power. Does that make sense? So when you see a variable or a number even all by itself, that's still raised to the first power. It just means that number all by itself, that number one time. So when you have that variable, when you're doing this kind of operation where you're multiplying with the same base and you add the exponents, you need to remember that there's a 1 there. And 4 plus 3 plus 1 does equal y to the eighth. So now they match. Does that make sense? We're not going to make that mistake. Okay. So this next one is a little tricky because it's got numbers in there. Ooh, not just variables. And so now I'm not really sure what to do. I'm a little nervous about this one, but I think that I should multiply the numbers because remember, this is just a multiplication, and then use the rule for the powers. So if I just multiply the numbers, I really have 7 times 6, right? Because it's a multiplication problem. And then I have y to the fifth times y. And that y is really y to the power of 1. Okay. So 7 times 6 is 42. Okay. And let's see, using the rule, if the base is the same, I add the exponents. What is my final answer going to be? What's the number out front? 42. Is that 42? Okay. So 42 y to the sixth power. Good job. All right, let's look at that next one because it's just getting a little bit harder. So we know that we need to multiply the numbers first, right? So I'm going to take -3 and multiply it by 5. That's the first thing I'm going to do. And then I'm going to take my bases are the same. I'm going to take x squared times x to the what power? This to the first power. This x is all by itself. So x to the second times x to the first. And then I have also y to the seventh times y to the sixth. I'm just breaking each one of these up. I'm grouping them by their terms. I'm putting the numbers together, and then I'm putting the like variables together so you can see what's happening. And then we're going to just kind of smash it all together at the end, right? Because it's a multiplication problem. So what is -3 times 5 is -15. Good job, Austin. And what is x squared, or x to the second power, times x to the first power? X to the third power. Do you guys remember the other way to say that? Instead of the third power, we could say cubed. We could also call it cubed. And what about y? Yeah, because we're adding the 7 plus the 6. So our final answer, when we bring it all together, is -15 x to the third power y to the 13th. That's a horrible looking 3, sorry. It just keeps erasing more and more. Okay, so x to the third power y to the 13th. Questions? You guys are awfully quiet today. Do you guys feel okay with that? Does that make sense? Have you seen that before? Yeah? No? You guys didn't do any of that in like pre-algebra stuff, 8th grade, anything? Okay. Do you feel all right with it? Because I'm going to add something else on it. So I want you to think, before I show you the next step, I want you to think about when you multiply, you are just really doing repeated addition, right? And that makes sense because multiplying is repeated addition. That's why we add the exponents. When you divide something, like if you take 28 divided by 4, you're just, to figure out the dividend, you're just dividing by 4. You're really repeating that subtraction. Division is like repeated subtraction. So the rule is when we divide, remember that quotient means divide. When we divide powers, we're going to subtract the exponents. When we divide them, we are going to subtract. Because again, division is repeated subtraction. So we're going to start with this first one. And I'm going to say the first thing is the base the same? Yes. Okay. What variable should go next to the denominator? What variable is actually attached to the y in the bottom? A 1. Okay. This is a division problem. So the rule says that if I'm dividing powers or dividing numbers with the same base, I take the exponents and I subtract them. So it becomes y to the 5th. Well, that's great, but sometimes my brain takes a little bit more to process. So I want to show you why that works because I think that's important. So y to the 6th power is really y times y times y times y times y times y over y to the 1st power, which is y. And we know how to reduce fractions, right? I have the same number. I can take 1 out of the top and 1 out of the bottom. What does that leave me with? 1, 2, 3, 4, 5. Y to the 5th. That's why that works. Okay. So for this next one, I'm going to expand it first. So let's see, 6, 13 times 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 10, 11, 12, 13. Okay, so that's 6 to the 13th over 6 times 6. And if I use that rule that says we can cross off 1 from the top and 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom, that leaves me with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which is the same thing as saying 6 to the 13 minus 2. It works the same way, okay? So I just want to explain to you, sometimes it might be easier for your brain to, especially when you have a lot of variable terms, sometimes it might be easier for your brain to expand it, right? And cross 1 off from the top, 1 off from the bottom. Sometimes it's just easier to use that rule, okay? Are we good? Is this making sense? I see, or okay. Okay. All right. This one. Well, we have to think about how we can simplify the two numbers here, first of all. And both of those numbers are divisible by what? Yeah, so first we are going to divide. Whoops, that says dive. Sorry. We're not going to dive. We're going to divide. Yeah. We are going to divide by 5. So I'm going to divide the 10 by 5 on both the top and the bottom. So the 10 gets divided by 5 and the 15 gets divided by 5. Does that make sense? So 10 divided by 5 is what? 2. Yeah, good job. 15 divided by 5 is 3. Okay, so we've taken care of the numbers. We're done with that. Now let's use our rule that says if we're dividing and the base is the same, we do what with the exponents? I hear someone saying it. Yeah, we subtract. What is 7 minus 5? 2. So that's going to actually go up in the top. Why is it going to go in the top and not the bottom? Why am I putting that a squared in the numerator and not the denominator? Well, I'm going to go back to that idea of expanding. So I'm going to kind of do some scribbling off to the side here to get us to think about what really just happened. I want to change the color though. It's not working for me. Here we go. So what really just happened? I had A times A times A times A times A times A times A over A times A times A times A times A. When I cross off one from the top, one from the bottom, where are they left? Are they left in the top or are they left in the bottom? They're left in the top, right? That's why those go up in the top. So kind of the idea when you have a fraction is that if the larger exponent is in the top, that's probably where you're going to end up with it, in the top. If the larger exponent is in the bottom, that's probably where it's going to end up once you use the rule, okay? Talk to me about this one. This is crazy. What happens here? They're the same. Here's what I found. Oh, be quiet. They're exactly the same. So that's the same thing as saying the rule says that we do b to the 9 minus 9. What is 9 minus 9? What is it? Just 0. Cetera, right? 0. Logan, what is anything to the power of 0? Yeah, this just equals 1. Now, if that's twisting your brain a little bit, I want you to think about what this really means. This is exactly the same term. You have exactly the same in the top and the bottom. That is no different than having 4 over 4, which equals 1, or 9 to the 278th power divided by 9 to the 278th power. They're exactly the same. They're exactly the same. That's why it equals 1. Okay? So this is our final answer. What do you think about that? Okay, we're going to do 2 more examples. The first one is anything to the 0 power. Oh, go back. Yeah. Lo siento. Anything to the 0 power. The first rule that we're going to talk about is 0. Yeah, 0 as an exponent. 0 is the best exponent. I put on my last semester, I wrote a problem much like Logan gave us yesterday. It was a ton. It was like 17, x to the 15th power, y to the 207th power, z to the 11th, all inside of a parenthesis raised to the 0 power. And I had students in my class trying to figure out what 2 to the 11th power was and just doing crazy stuff. But anything to the 0 is just 0. Okay. All right. So we're going to talk about 0 power. So any non-zero number, so any number that is not 0, 1, 2, 3, 4, 5, 1/2, 1/8, 2/7, -11, -12, any number to the power of 0, and that means any variable as well, is going to be 1. And let's talk about it. Why? Well, if I were to expand this like we've been doing, this is 8 times 8 over 8 times 8, which is the same thing as 64 over 64 and 64 divided by, that's what a fraction means, divide, right? 64 divided by 64 is 1. So if you have the same in the top and the same in the bottom, it equals 1. But using the rule 2 minus 2 is 0, and that's why it equals 1. So let me explain what I kind of just tried to do there, because sometimes we have a hard time understanding. So the first thing that I did is I expanded it, because that's what you saw yesterday. Yesterday you saw us expand it, and then I told you what that expanded answer was, right? 8 times 8 is 64. Then I reduced that fraction because you guys know that a fraction is the same thing as division. We know that equals 1. Then I used the rule that you just learned to make your brain understand what's really going on. When we divide, we take the exponents and we subtract them. 2 minus 2 is 0. But we know that anything that has the same in the numerator and the same in the denominator equals 1. That's why any number to the power of 0 is 1. So does it make sense how I like kind of dragged you through the mud to get you there? Awesome.
But then it's also 8 degrees.
It does look like 8 degrees. Yeah, you're right. You're right. But it's not. It's not a degrees. If I need to fix the way I write those, I can. But yeah, it does look like that. Okay. So let's look at this first example. So this first example says this whole thing is being raised to the power of 0. What does that mean? That means that whole thing equals what? That whole thing equals 1. Okay. Well, hang on a second. Yeah, that's it. That's it. That whole thing equals 1. Let's look at this next example. What is being raised in the next example? What is being raised to the power of 0? What is that exponent attached to? It's only attached to the x. It's only attached to the x. So the 8 stays the same. This turns into a 1. So I really have 8 times 1 plus 5. So what is 8 times 1? 8 plus 5, which equals 13. So any number to the power of 0 is 1. Any variable to the power of 0 is 1. Any grouping to the power of 0 is 1. Okay? All right. Let's talk about negative exponents. I'm going to draw on the board for a second. Don't laugh at my drawings, but I think my drawing will be better for everybody. So, does everybody know, like, if I were to kind of, well, that's a little, let's see. I'm just going to make it one dimensional. Maybe not. I don't know. I don't know how to do it. I'm just put a pillow right here and a person.
Oh, baby crib.
It's not a baby crib. So we got this person like sleeping. And then what am I putting down here? A what? Yeah, this is my illustration of a bunk bed. I don't know, he's trying to kick someone at the ceiling. I don't know. Okay, so do you guys know what it is to sleep in a bunk bed?
Unfortunately.
Yeah, does that make sense? 2 beds on top of each other. Como se dice en español bunk bed? Bunk bed? Is that okay? So here's how I think about negative exponents. Okay, this is kind of like the best way to think about a negative exponent. Every time you have a negative exponent, I want you to think of it as a bunk bed. So let's say that I have 5 to the negative 2 power. Okay, listen up. Stop talking while I talk. That's really disrespectful. This is the whole number 5. So it's really over 1. Top bunk, bottom bunk. Okay? If you are in the top bunk and you're negative means like you're fussing, you're sad, you're being crabby, whatever, right? You're not happy in the top bunk. Your mom is going to move you down to the bottom. But she doesn't have to listen to you fussing. Okay? Now this guy was happy where he was. He's going to stay down there, and this becomes a multiplication problem. We need to have something in the top, so we fill it with a 1. So I have 1 over 1 times 5 squared. Well, 5 squared is 25. So I have 1 times 25, which is just 1 over 25. So when you have something like this, it's negative, I say you drop it positive. Drop it positive. Okay? That's all you're doing. Now suppose that you are in the bottom bunk and you're unhappy. Let's say that you're in the bottom bunk and you're unhappy. So I'm going to give you an example of that before we finish our notes. I just want to show you. So if you're in the bottom bunk, you're in the bottom bunk and you're like kicking the top, right? You're throwing a fit. And your mom comes in the room and she's like, what the heck is going on? You're not happy down here. What are you going to do? Get moved to the top. Now you're happy. But this is still in the top. This is now a whole number over 1. 2 squared is 4 times 3, which just equals 12. Okay?
There's 12 people on the bed.
So there's 2 people on the bed, yeah. So hang on a second. Oh, 12, yeah, there could be 12 people. I don't know. So hang on. Let me do one more example and then we'll go through the notes. One more example. So I think this is the best visual. So I'm in the top bunk, throwing a fit. My sister is in the bottom bunk and she's throwing a fit. What should I do? What am I going to do? Alicia, open your eyes. Yeah, swap places. Move her down here, and now she's happy. Move this person right here. Now they're happy. 3 squared is 9, and 2 squared is 4. That's how that works, okay? So negative exponents can be really scary, but if you think of them as a bunk bed, you're just moving them from the top to the bottom. So let's see why that happens. Let's figure out why that's true. Let's see. Well, the rule says that if I divide powers, I subtract the exponents. And 2 minus 5 is, in fact, -3. And we're not allowed to leave a negative exponent attached to any number. It's just called mathematically, it's not mathematically appropriate. It's kind of, I always say that that's mathematically gross. It's just gross, right? Well, if I were to expand this like we were learning before, if I were to expand this, b squared is b times b, and b to the 5th is b times b times b times b times b. And remember I said if you have the same term in the top and in the bottom, you can take one away. Take one from the top, take one from the bottom. Take one from the top, take one from the bottom. Where are your b's? Are they in the top? The stuff that's left over, is it in the top or is it in the bottom? It's in the bottom. How many are in the bottom? 1, 2, 3. I have to put something in the top, so I put a 1. That's why this gets dropped. Move them to the bottom bunk, and they're happy. What do you think about that? So when you move someone from the top bunk to the bottom or vice versa, you're not changing the number. You're not changing the sign of the number if it's got a sign in front of it. You're changing the sign of the exponent. Okay? You're changing the sign of the exponent. So let's look at this example right here. Remember, it's over 1. I'm throwing a fit. I'm in the top bunk, screaming crazy. What do? Move it where? Yeah, I say drop it positive. Put them down to the bottom bunk. Now they're not crying anymore. I still have that 1 down there. It's a multiplication problem. And I have to put something in the top, so we fill it with a 1. So I have 1 over, what is 2 to the third power? Let's see. 2 times 2 times 2. 2 times 2 times 2 times 1 is, yes, 8. 1 over 8. Okay. If I left it as an exponent, I would leave it as 1 over 2 to the power of 3. I need to erase that and try to write it a little bit better. So it would be 1 over 2 cubed, positive 2. That exponent is positive, which equals 1 to the 8th. When I look at this example, what's getting moved down to the bottom? What am I moving down to the bottom? The -3 is getting moved down to the bottom. And my exponent is now going to become positive. It's going to be happy. So that's what your answer is. And it really means this. It means -3 times -3 times -3, which is actually 1 over -27. But this is acceptable. I just want you to know how to move it. Just want you to know how to move it. Up and down, up and down, up and down. So the exponent is what changes the sign. The exponent changes the sign, not the number. The sign on the number doesn't change. The sign on the exponent changes when you move it from the numerator to the denominator or vice versa. Think of it as a bunk bed, and hopefully that will help you. Okay? All right, so I'm gonna stop the share. So that's gonna stop my recording.